Yeah, this is a group of brachiopods that I've been obsessing about for quite some time, and I think those three people there on this slide are the only ones who are obsessing about this group, but I hope to convince you that it's an important one. The chileids, very enigmatic group, and for obscure reasons, it's mostly been found in very distant and very exotic, very strange areas. Here we are in Israel. We also went to Jordan this time to look for this very, very strange Cambrian group. They are some of the earliest calcareous shelled brachiopods, and we think they are quite important. As you will see, we have been doing this for quite some time. Some time has passed since that photo was taken. But lately, I mean, there are chileids turning up in more civilized areas, and I'm very grateful for, or possibly turning up in more civilized areas. There are some very, very good hints of possible chileids in these Montagne Noire sections that Leah and Sebastian very kindly have been taking me to. So I have great hopes for that. Chileids, yes, they are definitely some sort of calcareous shell stock. They are very early. They turn up, like I said, among the earliest calcareous shelled brachiopods with a strophic, straight hinge line. And of course, they are in most, or well, I mean, there are several cladistic analyses, but I mean, in the ones that we've been doing, particularly for the treatise, they invariably turned up somewhere in the stem of the runconelliforms or the articulates, if you so wish. I usually give inarticulate presentations at this meeting, but now I will try to be more articulate. Sorry about that. So yeah, I don't know how many times we can do that, but so the chileids have been exclusively known from the Cambrian, but the object of this is to show that we also have some potential Ordovician-Silurian stocks. They also, rather curiously, seem to be related to a very, very strange later Paleozoic group, the Dichtonellids and the isogrammids, which are similar in some respects, but also completely different. And possibly they also have some sort of relationship with these strange obolellids and Cutorgonids. So they are, like I said, one of the earliest known calcareous brachiopods, strophic straight hinge with a delthyrium, and most strangely, this sort of ventral umbonal perforations, which most commonly is partly covered by a plate, which have been termed a colleplax. It's a very, very strange kind of morphology. Yeah, I mean, they occur possibly in the base of the articulates, but of course they don't have any articulation as such, and they cannot possibly have had an articulate type of opening mechanism, because there is no way you can get a diductor muscle to work there. We hypothesized that they had some kind of hydraulic opening mechanism, perhaps like the recent cranids today. And like I said, yeah, they are very, very strange exotic areas, Kyrgyzstan and Israel, and they so far mostly known from this very coarsely, rather disappointingly coarse silicified shells. And one of the most wonderful and beautiful field areas I've worked with Leonid mainly is in these very distant parts of southern Kyrgyzstan, where these are olistoliths, so it's not part of any in situ section. They are all sort of scraping off some sort of stupid continent. But some of these, they have lots of different age olistoliths, and in one particular case, they contain a very rich fauna of these chileids. Unfortunately, we were unable to relocate this olistolith, but we found lots of other nice material. So basically, the first samples that were sampled by Leonid are the only samples we have from this region. The chileids in the treatise seem to group together with these very strange and much more derived dichtonellids and isogrammids, and they, of course, have a completely different opening mechanism. They don't really have any articulation as such, but they definitely have a cardinal process and a articulate type of opening mechanism, so they are quite different. The matotellids are a bit more, also very strange, but they occur both in the US and in Siberia. But that's the record of these chileids. But we're suggesting that some of these very strange late Ordovician and Silurian forms that have been masquerading under other groupings actually are the first record, post-Cambrian record of this rather enigmatic group, and still, you know, lots of gaps there. We don't really know what is going on, but I think this group is quite important for understanding the origin of the articulates, as it were, and they have a very strange structure. This quite well, I don't know if it's well known, but it's been around for some time, of course, described in Davidson's work by manuscript by Salter. Wenlock form. Most of these specimens come from around Dudley. Very uncertain localities. I've not been able to really pinpoint some of these enigmatic names that Davidson uses. But it's clearly by associated fauna. It's clearly a Wenlock form, and it was first described as a dinobulus, sort of trimerellid-like brachipod, and then later on referred to Gasconsia, which is a very enigmatic brachipod. That is, I will talk some about quite soon. They are invariably preserved as internal molds, although they occur together with lots of calcitic forms that are beautifully preserved, with shell and everything. These are all invariably internal molds. And of course, the general idea with the trimerellid assignation is that this type of preservation seems to indicate that they may have been aragonitic. And of course, lately, Uwe Balthasar has actually been able to find aragonite in some of these true trimerellids, but these are not true trimerellids. They have a very strange structure. Oh, and that's just for comparison. Dave Harper and Hanken's description of this best-known member of Gasconsia, which lacks all of these very strange odd structures that we have in the center of the ventral valve. And zooming in on them, putting them under the SEM and analyzing them, it's clear that they are phosphatic. So that's this triangular structure in the center, with also some scars, muscle scars on each end. And zooming in on all these that's also a phosphatic structure. It was at the side. It's just a little piece of the external surface of the brachipod, which also is phosphatic. And all of these structures are completely permeated by these filamentous phosphatic cylindrical structures. And it seems that something simply has sort of excavated whatever was the original composition, presumably organic, of these structures. So very fine sort of filamentous structure is replacing whatever the original structure. Some sort of indication of sort of preferred orientation of these cylinders, but I didn't really have a very good explanation. And also, I presume we interpreted that as a similar thing happening in the Periostracum. We also have these on Gotland, erratics, slightly older, most likely by the associated fauna, Clandoveri ones, erratics. And they also have this very strange structures, a much more sort of rigid shell with very nice mantle canals, pinnate mantle canals. And zooming in on that structure again, we have this clearly phosphatic, triangular kind of pad-like structure with not identical, but still sort of evidence of sort of cylindrical filamentous structure and some pyrite, of course, as well. Gotland, of course, I should do some promotion. Gotland is now part of Uppsala, I hope you realize. We have taken over the island. No, we haven't. We have entered into a happy marriage together with the previous university on Gotland. So I can now do fieldwork on Gotland without leaving Uppsala campus, which is very good. The last and oldest member of this very strange group is the one we know the least of. It's from a very distant part of Kazakhstan. And we don't have any trace of any mineralized structure here, but it clearly is a triangular structure that sort of penetrates through the otherwise very ribbed and ornamented shell in exactly the same region that we found in the other forms. And we are suggesting that this, like in the Cambrian chileids, represent some sort of colleplax structure. This is a term that was first proposed by Tony Wright for these later Paleozoic dictyonellids and isogrammids, and he suggests that it was some kind of chitinous pad, which was never has been preserved, that kind of attached this region directly to the substrate. However, there is this very, very strange silicified member of this clade with something emerging from the holdfast, and I actually think Tony didn't think it was the holdfast, but I think it may well be this type of colleplax holdfast. And we actually have, this is work I've done together with Shifei Zhang from Xi'an on some of these strange Qianyang brachiopods. We are suggesting that this is some kind of very early chileid-like form. It has sort of a strophic hinge line, a very, very short body, some very strange leucophorial imprint, and the shell is like these Silurian things from Britain, very poorly preserved. It's always completely sort of squashed and deformed, and the only rigid structure is this thing that surrounds the pedicle or the attachment, which clearly came only from the ventral umbo, and it's surrounded by the shell. And we are suggesting that this could possibly be a soft body preservation of something similar to one of these later chileid-like forms. The only well-preserved chileid that we have that is not silicious is this single valve from Australia of what is apparently a phosphatized chileid, again with this colleplax-like structure and actually a very nice larval shell, but unfortunately it's the only specimen. Yes, a bogogram. Like I said, the chileids in real chelistic analysis tend to branch out very close to the Rhynchonelli forms. But in this work, we are suggesting that this type of colleplax structure actually can be traced back to even some of these primary phosphatic forms. Salangolina is a very strange sort of mix of patrynid and chileid brachiopod, and even more interesting into some of these tomotid forms that Leah has been talking about earlier. It's a very, very odd structure, this kind of umbonal thing with this plate-like structure, and we are suggesting that it is an homologous structure that subsequently probably was lost in the more derived articulates. Thank you very much.